Hi, welcome back to Dr. Zakir Math. Today we are starting section 1.8 continuity. In this video, we will quickly check where the functions are continuous and where they are discontinuous. Again, I'm telling, I'm not going to check continuous or discontinuous. I'm going to do in this video first set of problems where functions are continuous. Where functions are continuous. Okay, continuous, and where the functions are discontinuous. Discontinuous means what? Not continuous. Mafi continuous. Keep in your mind, right? I'll show you simple shortcuts to spot discontinuity fast, so you don't get anywhere stuck, right? So let's get started. Before going to this, let me give you some shortcuts. What is the shortcuts? The first step you have to remember is, if the denominator, okay, you're going to put what? Denominator equal to 0. If you put denominator equal to 0, you will get discontinuous points. You will get what? Discontinuous points. Again, I'm saying, if you make the denominator equal to 0 and if you solve for x, then you will get discontinuous points. Keep in your mind. Again, I'm telling, put denominator equals to 0 and solve for x. If you do this step, you will get only discontinuous points. Clear first point? Next. Number 2 is about polynomials. What do you mean by polynomials, teacher? Polynomials means the power of x or non-negative integers. What do you mean by integers? Integers means 0, 1, 2, 3, so on, infinity, right? So the power, for example, x to the power of 20, x to the power of 4, x to the power of 5, x to the power of 6. If something they give in the question, right? These are all polynomials. So all the polynomials are continuous everywhere. You no need to check. Just you can write simple words. Polynomials are continuous everywhere. Okay, right. These 2 points you have to make it very clear. The first one is make denominator equal to 0. If you make denominator equal to 0 and if you get the value of x, that x values are discontinuous points. It means the function is discontinuous at these x points. Clear all of you? Right. So this is video number 1. That is part number 1. And video number 2 regarding continuity, that is part 2. I'm going to show that f of x is continuous and I'm going to show f of x is discontinuous. These type of questions I'm going to do in part 2. Is it clear, everybody? Right. So let's go to the first question. Where are each of the following functions are discontinuous? Where means they're asking you the points. They are not asking you to check. They are telling you where are each of these following functions are discontinuous. Just now I said for discontinuous, if the question is where they are asking, make the denominator equal to 0. Let me go to the first question. First question, what is your function? F of x equals x to the power of 2 minus x minus 2 divided by x minus 2, right? So what's your denominator? Your denominator, I put dr, right? Which is x minus 2 equal to 0, which implies what? X is equal to 2. It means, what is the answer you're going to write? You are going to write f is discontinuous. Again, I'm saying discontinuous. F is discontinuous at x is equal to 2. That's it. Because they are asking where. Again and again I'm saying, you are not going to check the function is continuous. You are going to tell that where the function is discontinuous. Keep in your mind. Okay, right. Let's go to the next question, B, right. For the question B, your f of x equals what? X square minus x minus 2 divided by x minus 2. I think the same question they have given, but in the interval it's given. Look here, this function we cannot take it because the value is what? 1 already given. So this one, there is no denominator, so we cannot take it. So x minus 2 equal to what? 0. So x is equal to 2. So it means the function is discontinuous at x is equal to what? 2. At x is equal to 2. So that's it. Both the problems are same. They gave example 1 and 2. But okay, it's not same. It is they have given discontinuous functions here. No problem. Right, let's go to the next question. Very easy question. Next one. Right, let's go to the next question. Where are each of the following functions are discontinuous? Again, the same type of questions. So what is the solution you're going to give? For finding discontinuous, you're going to make denominator equal to 0 and then just find what? X. So these x points are what? Discontinuous points. I think you're able to understand this, right? So what is your denominator? X square. X square equal to 0. So automatically x equal to what? 0. So what you're going to write? the function is discontinuous or it is discontinuous. Anything, English is not important. So it is discontinuous at x is equal to what? 0. Clear everybody? Right. So this finishes the set of questions for discontinuous. Let's see what type of questions in the next one. On what intervals each function is continuous? Intervals they are asking. What do you mean by intervals? In 001 you studied what do you mean by intervals, right? This is called intervals. Remember, this is called intervals. So the question is, on what intervals the function is continuous? Never mind continuous or discontinuous, no worries. Okay, continuous also, discontinuous also, you are going to do the same procedure, right? Okay, let's start the first question. What is the first question? A, what is x power 100 minus 2x to the power of 37 plus 75? Is there any denominator here? I'm asking you, is there any denominator here? Denominator means down. Is there any denominator here? Again I'm asking, is there any denominator here? No. So then what kind of function is it, teacher? I told you polynomial functions. Remember, what do you mean by polynomial functions, teacher? Polynomial means the powers are non-negative integers. The powers are what? Non-negative integers. What do you mean by non-negative, teacher? Non-negative means, negative means what? Minus. Non-negative means what? Positive. What do you mean by integers, teacher? Integers is 0, 1, 2, 3 like this. So if the power is 0, 1, 2, 3 and so on, power, again I am talking power. If the power is 0, 1, 2, 3 so on, then it is called polynomial. Then it is called what? Polynomial, right? X to the power of 100, yes, it is a integer. X to the power of 37, yes, it's an integer. Teacher, here there is no x. X to the power of 0. 0 is an integer power, right? So automatically this is what? Yes, it is a polynomial. It is a polynomial. Okay, where is polynomial continuous? I told you in the beginning itself. I think might be I wrote it or not. I'm not sure, but I told you polynomials are continuous everywhere, right? I wrote it, yes. So polynomials are what? Polynomials are continuous everywhere. Everywhere means what, teacher? All, minus infinity to plus infinity. So the next you're going to write polynomials, okay, are continuous, okay, everywhere. What do you mean by everywhere in mathematics? Everywhere in mathematics is minus infinity comma infinity, right? Infinity is not included, minus infinity is not included. Keep in your mind. So whenever you get polynomial equations, directly you can write the answer like this. What type of answer? Yes, it is a polynomial, right? And for this polynomial, it is everywhere, it is continuous. Wow, nice question. Let's go to the next question, g of x. That is question B. Let me write this is A and we go to question number B. Okay, let me see the question. What is the question? 2x 17 x square minus 1. So the question number 2 is g of x equals 2 and then plus 2x and then plus 17 divided by x square minus 1. Am I right? X square minus 1. Yes, correct. Right. So what are we going to say? No discussion because we have denominator. Correct? No discussion, we have denominator. Of course, this is a rational function. I don't want to confuse you rational functions and all here. So now what I'm going to do, I'm going to make the denominator equal to 0. What is the denominator? X square minus 1 equal to 0. So if you go to the calculator, mode, okay, 5 and then 3 because you'll always make mistakes. Mode 5 and 3 and the calculator will show you A, B, C. What is A? Coefficient of x square. Mu'amal x square. What is B? Coefficient of x. Mu'amal x. Mu'amal is an Arabic word. And C is rakam. Rakam means what? Number. Okay, right. So what is A? Coefficient of x square? 1. What is coefficient of x? There is no coefficient of x. 0. So number is what? 1. Come on. Put the calculator. 1 equal 0 equal minus 1 equal. So you will get x is 1 is equal to plus 1 and you will get x2 is equal to minus 1. Are you getting? Right. So x is equal to 1 and x is equal to minus 1. X is equal to 1 and x is equal to minus 1. Clear everybody? Right. What is the meaning of this? It means the function is discontinuous at these points. Clear everybody? Usually one question I did, remember or not everybody? One question I did making the denominator 0, 0. What I write here? You see here? So I made the denominator equal to 0. So I got the points. What I wrote? Discontinuous at x is equal to 2. So the same answer I'm going to write it. Same answer I'm going to write it. What I'm going to write it? What I'm going to write it? Tell me. So the function is discontinuous. The function is discontinuous at x is equal to 1 and x is equal to minus 1. It means what? It is not continuous. Am I right? It is not continuous at x is equal to 1 and x is equal to minus 1. The previous question, the question was what? Check where the functions are discontinuous. So you gave the answer like this. But now look at this question. What they are asking, just opposite word. They are asking what? Check where is the function continuous. So if I make the denominator equal to 0, that point is discontinuous. Okay. So where is continuous? Other than these 2 points. Remaining all the places they are continuous. Understand everybody? Right? Suppose I take a line, okay? So here is the point 1 and here is the point minus 1, okay? These 2 points are what? These 2 points are discontinuous points. These 2 points are what? Discontinuous points. Again, I'm telling these 2 points are what? Discontinuous points. Why? We made the denominator equal to 0. So this is a discontinuous points. But what is the question now? The question now is check where is continuous. The previous question is what? Discontinuous. This question is what? Continuous. So what is your answer? I hope you are all engineers, you can say. So all these places the function is continuous, correct? Continuous or not? Yes. And these functions are what? These places are what? Continuous. So what I'm going to write it? Yes. In which places it's not? Except these 2 points, remaining all the places are continuous, right? So I can write in two type of answers. Look here. One answer I'm going to write starting from minus infinity and going to plus infinity. Look here. Minus infinity comma minus 1 union, minus 1 comma 1 union, and 1 comma infinity. It means all the points I included except minus 1, except minus infinity, except minus 1, except 1, except 1, except infinity. Remaining all points are included. How, teacher? You wrote all the points and you say it is not included. See, when I put this bracket, it means what? This is not included. When I put this bracket, what is that? This is not included. In between, all the points are included. When I put this bracket, this is not included. When I put this bracket, this is not included. In between, all included. Correct? Yes. So when I put this bracket, it is not included. This is not included. In between, all included. Teacher, it's so difficult. How can I remember? I cannot remember all these things. It's so big, teacher. Okay, in a simple way, I'll tell you. Just write R, okay? And then you write a cross line like this. Skip. Skip, you can say skip or minus, whatever you can say. And then open a curly braces. You know curly braces? This is called curly braces. You write the points, what you got for the x points here, right? Okay, x is equal to plus 1, comma, minus 1. Okay, you can write also like this. So, because plus 1 and minus 1. So, either you can write this answer or this answer. Both are correct. But actual correct answer is this one. Why? Because in the question, they are asking intervals. Look here. Intervals they are asking. Interval means what? I said like this, right? Intervals. So, first answer is correct. But sometimes the second answer also they will say, okay, no problem. It's also a kind of interval. So, nothing to worry. Clear all of you? So, the first problem I did is what? Continuous. Second problem I did, first problem I did is what? Discontinuous. Second problem I did is what? Continuous. Clear all of you? So, whenever a function has a division means what? Numerator, denominator, like this. This is division, okay? This is called division. This is called what? Division, okay? Whenever there is a function is having a division, check whether the denominator is 0. So those points are where the function is not continuous. Not continuous means what? Discontinuous. Clear? Let's go to the next interesting problem. Where are the following functions continuous? Again, they are asking continuous, right? Let's go to the solution now. The denominator is square root of x square plus 7 minus 4 equal to 0. I want to find the value of x. So what I will do, this number I'll take this side. Square root of x square plus 7 is equal to 4. I want to remove the squares. So what I will do, I will make squares both sides. When I make square both sides, I will get x square plus 7 is equal to 4 square is 16. So x square equals 16. The 7 goes that side. I will get minus 7, right? So x square equals 16 minus 7 is what? 9. So taking square root of 9 plus or minus. So x equals plus 3 and minus 3. Okay, right. Okay, teacher, why plus 3 minus 3? Because always square root of a number has what? Plus or minus, right? What is the question? What is the idea from this? The idea is, look here. This is the point 3 and this is a point minus 3. These 2 points are what? Discontinuous points. These 2 points are what? Discontinuous points. Discontinuous points. Okay. These 2 points are discontinuous points. Now what is the question? The question is, they are asking you, where are the following functions are continuous? It means what? You have to exclude these points. You have to exclude these points. How I am going to exclude? I told you this is minus infinity, this is plus infinity, right? Yes. So how I'm going to exclude? Minus infinity, right? Comma minus 3 union minus 3 comma 3 union 3 comma infinity. Writing like this is called what? Interval notation or interval form. They are asking interval. Okay, teacher, I cannot write like this. Okay. So what should I do? I told you already, very simple. Set of all rational numbers or whatever real numbers, whatever you say. And then you just put a line, except you can say, and then put a flower braces, right? Minus 3 comma plus 3. Is it okay, everybody? So simple. This finishes 1.8 part 1, right? Most of you are feeling the video is too lengthy. So that is why I'm just doing what? As cut into 2 pieces. After uploading, I cannot cut into 2 pieces. So that is what I'm doing. So I'm making as a short videos, half an hour, something like that. Okay, great job, babies, right? In the next video, we will explain. Next video, it means the part 2. The part 2, why these functions are continuous and discontinuous using the definition. I will tell you what is the definition. So you understood the why, right, behind this. So don't forget to like, subscribe and turn on notifications to not miss part 2, right? See you in the next video. Take care. Until then, signing off, Dr. Zahir.